Okay, we were given a graph of y equals 2 to the x. Graph made by the computer. You had rather large dots on these points, so your points kind of look like this. And so forth. So, to see exactly where the graph is, because there wasn't a nice smooth line through the points, you have to look at the center of each dot. Okay, and that's kind of important, because if you don't do that, you don't get as accurate a result, although you still get the idea. Okay, it is kind of fun to get an accurate result here. You'll see what I mean. Okay, y equals 2 to the x. If this is a graph of y equals 2 to the x, there's one point on this graph that you can definitely label. Only one. What point would that be? Excuse me, I had to step away for a second. The hall might be about to get a little noisy. It's pretty quiet right now. So I've kind of pulled the door. Okay, what point on this graph do we know for sure? We know this point right here has to be 0, 1. This is the y-intercept. 2 to the 0 equals 1. So this point is 0, 2. I'm not sure if I said something a minute ago about that, but this point is, it's not 0, 2, it's 0, 1. I guess it's getting late in the afternoon. Okay, this point is 0, 1. Okay, there's no ifs, ands, or buts about it. The only place x is 0 is here, and the only value you can have for y equals 2 to the x, or any base to the x power, when x equals 0, anything to the 0 is 1, so the coordinate here has to be 1. Now this allows you, so this is where y equals 1, everywhere to the right and left here. Okay, where's y equals 2? Well, it's twice as far from the origin as y equals 1. So we just go up by this increment here and we get y equals 2. So if this increment is equal to this increment, there's y equals 2, and we go up by the same increment, we get y equals 3, we get y equals 4, 5, 6, 7, 8. Well, I don't know how well I did to keep those increments the same, but if I did a good job, and if I happened to have drawn a good curve, and I was kind of on a roll with that yesterday, maybe what we get here is going to give us a good result. If it doesn't, we'll be able to point out just what constitutes a good result and what doesn't. Okay, so now we need to label the x-axis. Okay, how are we going to do that? Well, we know that when x equals 1, y has to equal 2, right? So y equals 2 everywhere along this line here. And in particular, y equals 2 hits the graph right here. So the coordinate directly below that point had better be 1. So 2 to the 1 has to be 2, so the point 1, 2 has to lie on the graph, right? So this is the point 1, 2. And I want to label that, okay. Now, to check for consistency, let's check the point 2, 4. Where's that on the graph? Well, we've got the y-scale. Up here is 4. Here's where y equals 4. Okay, if we come straight down from there, we get here. And that should be where y equals 2. Now, if you've done this correctly and with a really accurate graph of the exponential function, which you have if you treat it right, these two distances should be the same. So if you've done it right, these two distances should be identical. Now, my distances aren't quite identical. This is only about 90% of this one. Now that could be because of the way I did my projections. Maybe I was going a little bit down when I should have gone a little bit up. And maybe it's just the shape of my curve. We can check y equals 3. Okay, y equals 3, x equals 3 gives us 2 to the third, that's 8. So that should be a point out here. We're going to intersect the curve about there. That's going to be down about here. And that should be 3. Now, it looks like this distance is a little less than this, is a little less than this. So I didn't quite curve this right. Okay? Now, when I did it in class, I did. So we're going to see the graph that I made in class. Not so I can show off. Of course, I love to show off, but just so we can understand the exercises we did in class. Okay? Now, I need to check the camera. Matter of fact, I'll come back in another video. I'll reset the camera off video.